Oh, and I think I had you, did I have you do the thing where you took a value and rounded it to X number of significant figures? Like it was like 206,000, blah, 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 whatever it was, right? Okay, we did that. Good. Try this on for size. Some of these aren't very hard. Okay, try those first. And actually, as it turns out, a couple of these examples I'm going to use to cover a couple of other things that we haven't addressed yet. Might as well get this hook back up. Oh wait, that's my Apple TV. I already have that. This is this shan't take you long. I don't like when big cords hang down. All right. On your calculator, in your head, on paper, what did you guys get for this one? The entire thing. What did you guys get? Anyone? Okay. I'll do it. You should have gotten 397.978. Is that right? That is not the one. My bad. You should have gotten 35.329. Oh, wrong one. 35.329 milliliters. This next one, I can't remember which order I did it in. Did you get 2.0, sorry about that, 8.445? We'll come back to that one. The next one, did you get 9.271? Just did straight up, 4th grade, addition, whatever, okay? And then the last one, you probably should have gotten something like 55.38, yes? All right, we're going to cover 2 of them right away, and then we're going to come back and do the other 2. We're going to save this one and this one. Okay, let's do this one first. Obviously, addition. To what precision level is this measurement made? And this one is measured to the hundredths place. Therefore, we are going to round our answer to the hundredths place, which is right here. So the correct answer would be 35.33 milliliters. Everyone hunky-dory. Pretty darn easy, wouldn't you agree? Okay. Let's look at this one. Once again, we're doing addition. You add all these things up, we get not bad. And we get 9.271. Obviously, this measurement is precise to the thousandths, tenths, and hundredths. Therefore, our answer should theoretically only be stated to the tenths place, which would be right here. And therefore, we would round this to 9.3 meters. Everyone hunky-dory there? Easy stuff, okay? Now, the next thing. The first asterisk, the top one, is actually not adding anything to your life. But I am going to use it to explain the thing that I am going to add to your life so that we can move on and apply it to the second asterisk, okay? Remember I introduced that concept of an accepted value when we were talking about accuracy? And where do accepted values come from? Well, they come from people doing large numbers of repetitions of the same measurement and or technique over and over and over again. And they essentially take the average of all those things and boom, here's the accepted value. That probably makes a lot of sense to you, I hope, right? Well, here's the deal. Here's the problem with that. We're adding, once again, we're going to go to the least precise place, which turns out to be here. Your entire life, you guys have done what at this point to round that to the hundredths place? You round it up because that's what you were told to do, right? And that's okay on a one-time shot. But let's say you're doing 1,000 repetitions, measurements of the same thing. And every time, let me ask you this, what is the is a 5 exactly halfway? Well, what are your possibilities? 1 in 10. No. Either way. Let's go 0 to 9. Yeah, well, here's where I'm going to go with this. If you round up every single time, you're going to skew your result higher. If you're doing 1,000 measurements and you round up every time, you run into a 5, this scenario right here that we're looking at. Isn't that going to skew your results slightly? Now, are you going to end up with a 5 every time? No, but it's going to happen on occasion, right? And if you round up every time, you're skewing your results a little bit high. So what we need to do is find a mechanism that half the time we're rounding up and half the time we're rounding down. That way we're going to balance out the rounding. Okay? So, here's a good question. The 4 that I underlined, that digit, that place, what's the probability of that being an even number? 50% of the time. Hey, we just found our mechanism. Okay? So listen carefully, because I'm really changing very little in your life. Okay? Very, very little. In a scenario exactly like this one, in which we're using a 5 for rounding purposes. Now, if it were a 6, a 7, an 8, or a 9, what would we do? We round up. We did that here. Automatically didn't even think about it, right? But now we have a 5. Is there anything after the 5? No, so it's like exactly 5. Now, if there was like a 5-1 or a 5-2, it'd have a little over half. What would we do? Round up, because it's a little over half, right? But the 5 represents half, halfway. And the probability of this being an even number is 50%. So what we're going to do, if the value that we're rounding, when there's only a 5 after it, is even, we're actually going to round down. We're going to keep it a 4. So the correct answer in this case would be 8.44. This is the only thing I'm adding to your life today. Well, for this. For this. But now let's look at this scenario. Here we have a measurement that is precise to the hundredths place. This one is precise to the tens place, is it not? So my answer can only be stated to the tens place, which is right there. Oh, sorry about that. Right here. So what are we going to round? 60. That's it. 60. There it is. Did anyone get that? Did you do that correctly the first time? Seems weird, doesn't it? But again, it goes back to the whole idea of Danny weighing himself this morning, okay, on the scale, and while he's standing on the scale, I come up and pull that hair off his head. The scale's still going to say the same thing because that particular scale was not able to have the ability to recognize that quantity. So this is my scale, what should I say, device, my instrument that was limiting my precision level by a lot. Remember, this is the value that was estimated. Yes?
So if that had been 45.38, would we look at it? Like 55.38, like 45.
Oh, no, because watch this. See, I see what just happened here. Remember, I only added one thing to your life. Watch this. 5. But there's things after it. You're the one that correctly answered over here where I said, oh, what was there a 1 after this? You said, oh, round up. Because it's over half.
Yes, I see that.
Okay.
I'm confused because 5 is the value we're rounding.
This 5.
Yes.
And there's more than halfway over here.
Yeah, but I'm changing.
Okay, so if I make this a 4, what are we going to do?
There's nothing after 5.
Oh, now you're throwing 2 things in there.
I get it now.
Okay. So we're done? Okay. That's okay. It was good. All right. Don't get your panties in a bunch about the whole even odd thing with a 5, okay? What is the odds that you're going to run into that? It's not going to happen. It will happen. It happens every year, but it doesn't happen that often. And that's more, again, applying to measurement. Don't go to your geometry class or whatever it is you guys are taking now. You know what I'm saying? I've only added what we do in this class, in physics or any other science classes, is take the math that you have learned and use it. Where in math, you're just learning the math. Does that make any sense? Now we're using the math for actual real things like measurements and experiments and all that kind of thing. So there's guidelines that you kind of follow. All right. Let me try a couple of multiplication and division. This is also easy, and I'm telling you right now that both rules, as I said yesterday, are easy, but you guys early on might have a tendency to mix and match the rules. Does that make you see where I'm going with that? So you just got to be really careful what you're doing. All right, let's try these. 2 more here. Okay, and I'll mess with you on this one a little bit. Okay, try those 2 on for size. Go Pacers. I had to bring it. It was in the other room for a few decades, so. Oh, battery's dead. Got to change batteries. Ooh.
Hey, drop it to 20.
all kinds of fun things in here. We'll get this out later this year. This is always fun. Huh. Apparently Kalen didn't take the AP Chapter 9 and 10 quiz last year because I still have his answer sheet. You guys done? Alright. On Z calculators or in your brain or on paper, wherever you got, this one you probably got, to start off with, 397.978. And what's the unit? Squared. Centimeters squared. Who was it? Was it anybody in this room that had their calculator on fixed mode? Yeah, so what was happening was depending on where you had your calculator, which fixed you had it set on, your calculator wouldn't give you anything past like the 100th place. Was that in this class that was true? Apparently not. Okay. Anyway, moving on. So we're doing multiplication here, so now we care about the number of significant figures, not where they are. This measurement has how many significant figures? 5, and this one has 2. So this answer result is going to be limited to 2 significant figures, which is right here. This is interesting. Did anyone struggle? Did you guys recognize that that's where we were going? That it was the 2 significant figures. Now it's going to be curious to see what you guys wrote down as an answer. Anyone want to offer one up that they feel somewhat confident in? Or would you like to offer up one that you flat out know is wrong so you can kind of avoid the embarrassment? Nobody wants to offer anything up. Becca's like, I don't want him to call on me. Are you saying that to yourself? What do you got? Okay. This one has a chance of being right. Is that right? What's that? That only has one significant figure as it's currently written. So there's a couple of different things we can do to fix that. Do not do this, because this comes up a lot. Some people say, oh, well, I'll fix that. But seriously, that happens, okay? And so I'm trying to get that out of the way now, okay? Some of you actually did that, didn't you? All right. And the old-fashioned way is this. That's fine. Did anybody do that just out of curiosity? Did you? A couple of you did. Nice. Or what's the best way? Did anyone do it that way just out of curiosity? Okay, so about 5 of you got that right. Okay, there we go. Good. And the next one. On your calculator, brain, whatever it is you did this on, you guys should have probably gotten, on my calculator when I did it, 0.644, 6281. Did anyone else's go further than that? Throw them out there.
I had 710.992.
So this is exactly what I was saying when we started this conversation about using significant figures in calculations. At what point would you guys have stopped writing down numbers? Because you probably made a decision at some point. Would you have, until yesterday, would you have made a decision to stop writing numbers down somewhere? Just out of curiosity, what would you guys have done? This 0.644, would you have rounded it to 0.645? Interesting. Would anybody have gone 0.6446? I think that would have been a fairly common one, because that would be the first place you wouldn't have to round up. Okay. Or how many of you would have written down the entire darn thing that was on your calculator? What's up there right now? Okay. Well, now you know the rules, except you don't know all of the rules yet, because now what's our issue with this particular problem? We have mixed operations, okay? So there's going to be a lot of times this year when we have either mixed operations and or multiple steps in a process. And the problem with that is, what students will do occasionally when they first start out doing this stuff is they'll start rounding at the end of every step. And if you think that all the way through, let's say you've got a 4-step process and you've rounded at the end of every step, that can have a significant difference make a significant difference on your answer, okay? So, here's the general rule of thumb here. We'll do our little, follow the order of operations, whatever, and I'm showing you this technique because this is when I create my solutions to all our problems and everything. If there's an intermediate answer, I'll put it in brackets like that, so that way you guys can kind of follow along with what's going on. So, anyway, so if we do the subtraction here, what do we get? 4.68, right? But that was the result of a subtraction. So technically, based on the information that's up there, that's only valid to the ones place. Would you agree with that? So what I'm going to do is remind myself that, yes, even though I did the subtraction, it's technically only valid to the ones place. So I'm going to put a little mark of some sort there to remind myself when I use that value for the next calculation that it's only valid to the ones place. Okay? Interesting. Okay, so then what I'm going to do is now I'm going to take that value, but what I'm going to do, and here's the rule of thumb, always carry at least one, if not 2 or 3 extra significant figures along in subsequent calculations. So, instead of taking 4 divided by 7.26, or if you decided to round that to 5 divided by 7.26, I would at a minimum use 4.6, and since there's really only one number after it and it's already on my calculator, I probably would have used 4.68 to do the next step. So you're going to carry the extra ones along and then round at the end one time. So we take out 4.68, divide by this. Now this is what you guys got on your calculator, so that's pretty good. So that means you took that into account at some point in time, probably. We'll find out. And that's what I essentially got, although I think mine stopped here. Doesn't matter. And now we're doing a division, so we've got 1 significant figure divided by 3 significant figures. So that means we are going to have to round that to there, so the answer becomes 0.6. Hi, Mrs. Kovach.
Can I get a bunch
Oh, yeah, I forgot about that. Yeah, let me...
I'm sorry, I don't want to bother you.
Oh,
Go ahead.
there's no bother. We've been so focused and finely tuned machine in here all period long, as I've been spending most of my time looking for things. I'm trying to think where I've got all the extra ones. You can just take the one out of there for now.
I'll bring it back today.
Yeah, there's extra ones around somewhere. Should be down on the bottom.
Awesome. I can take the...
Oh, yeah. What are we burning? Which student? I mean, which,
sugar and salt.
oh. I got a fun little demonstration sometime for you to do, but anyway.
Another day.
With sugar.
Thank you.
Yep.
Have fun, you guys.
Okay, unit. Yes. Unit. I had a question first. Unit. Grams what? There we go. Thank you. And this is, we have to touch base on this. I know you guys know this stuff, but sometimes you forget. Grams per milliliter. And Jake, what's your question?
Is it only valid to the 1 place because of the 51?
Yeah, well, no. It's to the ones place because when you subtract these two things, it's only valid to this. Now, that's a result of this only being to the ones place. Is that kind of what you meant? All right. Yes. All right. Pretty straightforward stuff, wouldn't you agree? You just have to practice it. And guess what I'm going to do? Provide that practice. You guys already have the practice. You knew that, didn't you? You knew that was coming, didn't you? Oh, you guys got the yellow ones. You're lucky. Oh, which one should we do? Let's do them all. 2 and 3, both levels. This one's going to take longer than 3 minutes. I'm just saying. It won't take that much longer than 3 minutes. What's that?
About 4.
Yeah, maybe 4-ish. Now, I don't know. I'm going to say less than 10. And there's how much time in the class? Is it 10? You guys might get done before the end of the period. Nicely done today.